Good morning, everybody, and welcome to this week's machinery safety webinar from Pilz. Today, we're going to be covering the various controllers that we offer in our product range. I'm your presenter for today, Jamie Thomas, and my co-hosts answering your questions are Rhiannon Gibson, Alec Bryce, and Jason Reed. You can type your questions into the toolbar to the right-hand side of the screen, and the guys answering the questions will come back to you there. You should all automatically receive a link to the recording when the webinar has been completed and uploaded to the website, and presentation slides are available upon request. So what we're going to cover today are the various ranges. We're going to start with the Sigma range, then we're going to go into the myPNOZ range. We're going to go from there to the configurable multi-2 systems, and then onto the safety PLC, the PSS 4000 range. So here's a little map of how all these products fit into the range that we offer. So starting with the X range, we're not going to cover that today because that's an older range, but they are still available all the way through to the PLC. So as I said, we'll start with the Sigma safety relay range. And this is the old school safety relays that many of you may be familiar with. As we said, we previously used to do the X range. Well, prior to that, there was the old PNOZ ones. So some of you may be familiar with them. No doubt there's probably still some of them big green bricks clicking away in panels out there. We moved on to the X range, and Pilz, being customer focused company that we are, made a different relay for virtually every single application that people wanted, and we ended up with a massive range of products. So when the Sigma range was designed, we tried to incorporate all the different safety requirements into a smaller number of relays. So they're made up generally out of base units with contact expansion. Keeps the profile lower, so more panel space, and then caters for all the different requirements that you would need. So they range from 12.5 mil and generally up to 22.5, and some of the bigger contact expansion modules we come on to later do have a slightly bigger footprint. So they can be used, and the idea, as I say, was to cover all aspects, whether that's e-stops, light curtains, guard switches, two-hand controllers, timers, all catered for in a smaller range of products. So this chart here is taken from the catalogue, and you can see there that the number of relays down the left-hand side and what they are capable of doing for the safety system, and then also the housing size. So like I say, they go up to 45 millimeters for your bigger contact expansions. So if we run through very quickly, worth bearing in mind that all these products are also available in a conformally coated version. So this gives you higher temperature ranges, so -25 up to 55 degrees, and they're also tolerant to condensation and things like that. So the first one is the S1. This is just a single channel relay, 2 normally open contacts. It will only meet performance level C as it's single channel, so you've got no diagnostic coverage on the actual circuit you're monitoring. However, some applications, potentially mainly e-stops, this may suffice for what you're after. The other single channel relay that we offer is the S2. Again, will only reach performance. It can reach performance level E in some applications, but what we'll be looking at mainly here is that there's actually a bigger contact expansion from 3 normally opens and 1 normally closed contact. But at this point here is where you can start to get selectable reset modes. So you can go with the rising edge of the reset button, the falling edge of the reset button, and you can also select automatic reset. So you can see here we've gone, the original S1 was 12.5 mil, it had 2 terminals, 2 terminal widths. 3 terminal width is 17.5 mil now with the S2. Moving on to the S3, this is the first one in the range that offers single or dual channel capabilities. And then with the selectable operating mode, although you can also still select your reset, whether you go to the left or the right hand side of the dial will determine then whether you're going to be detecting short circuits between your 2 channels. So that allows then to give you a higher performance level, higher diagnostic coverage, etc. for your switch. Again, this one is sort of similar in the range to the S1. We only have 2 normally open contacts with it, but it is capable of taking in OSSDs. So you could use the left-hand side of the dial for that, as you're not going to use the short circuit detection within the relay. That would be done within the switch or the light curtain. If you're using volt-free contacts, you use the right-hand side because then the relay is doing the short circuit detection. The S4 now is the again single or dual channel, but we have 3 normally opens and 1 normally closed. With all these relays, you've got your input, your S34 input, which is where your reset button comes in, and that's where you would series link your feedback contacts from your contactors, etc., or anything you want to monitor within the circuit to give you a higher performance level and therefore diagnostic coverage. Again, the selectable dial is the same for this, so whether you want to do your different reset types or whether you're looking at volt-free or series linkable or OSSD outputs will depend on how you select that dial. The S4.1 here is very similar to the S4, but it has extra approvals for furnaces. So the 50156-1 certification for the standard for that. But in essence, it operates in the same way. There are other relays in the range as well with slightly different part numbers which have multi-voltage capabilities. So if you're not just using 24 volts, you may still have a 110 volt control system. You can use them in these ranges as well. Once we move on to the S5, you can see here we have the timer features. So you have 2 safety contacts in this, which are instantaneous, but the other 2 contacts are delay on de-energization contacts. So you can create, there's a 3rd dial, as you can see from the illustration, and that is your timer dial. So the extra dials there depend upon how the time, and you can configure them with different clicks to the actual time that you want your timed contacts to open on. Again, single or dual channel, short circuit detection, all that sort of good stuff to give you diagnostic coverage, not just on your input and also your output circuits. Once we move on to the S6, we have 2 types within this range. So the S6 is a performance level E, because what that will look at is you have a normally open and a normally closed for the 2-hand controller. So this is for the 2-hand control applications, and you were looking then for the changeover in them 2 different contact types, whereas the S6.1 would just look at normally open contacts and look for both of them to close. There is simultaneity built into this. So what you're looking at there is these must also operate within a very short time period, so that one can't be pushed in and then held down, and then you essentially defeat the purpose of a 2-hand controller because you would still have a single button control. So you've got simultaneity of the 2 contacts being operated. So now we move on to the 6.1. Again, you can see it looks very similar, but it just operates differently. As I say, instead of looking for a differential between an open and a normally open, normally closed contact, you're just looking for a normally open. This now once we get to the S7 onwards, we're looking at contact expansion. So the S7, this would just clip directly onto the side of one of the base units. So for instance, the most commonly used base unit is the S4. So you can see there's a little yellow plug on the top of all these relays, and then you get a jumper bar which just clicks over the top. So there's no physical wiring between the base unit and the contact expansion. You just put your jumper bar in the top, and then that's how you start expanding these contacts. So the S7 has 4 normally open contacts and 1 normally closed. It's probably worth pointing out at this stage that any of the normally closed contacts we have on any of these safety relays cannot essentially be used for the safety of the system, because when they on de-energization they close and allow the control voltage through the contact. So as we know with safety systems, you're looking for a positive signal when the system is safe. So if there was a failure of any of these relays or someone removed the power, then the contacts would close and you would get power through your normally closed contact. So therefore, it's not essentially a safe contact. We have the S7.1 and 7.2 contact expansions. The 7.1 has 3 normally opens, the 7.2 has 4 normally opens and 1 normally closed. But what these allow you to do, these are cascadable. So whereas you may have seen, if we just click back one slide, there's one of the yellow plugs in the top where the jumper bar goes in for this. You can see there's 2 on these relays. So what that means is you will plug one in from your base unit or from your previous contact expansion module, and you've got another jumper bar which goes to the next one. So you can go there. You can have up to 10 7.2s in a line, but if you want to go further, then you have to add an additional 7.1 to sort of refresh the power across the system. S8 is a 12.5 mil wide contact expansion again. It only has 2 normally open contacts with it. So, but if you only need a couple of extra contacts, then this is the reason for this this version, because it will give you just what you want. And like I said at the beginning of the presentation, this range is all about trying to give the application suitable application with a smaller range of products. We also have timer expansions. So if you want to go down here, then you've got the S9, and you've got delay on de-energization and delay on energization available for this. So this isn't a base unit, it is a contact expansion, so you would need one of your base units with it. However, you can add this on for certain timed outputs that you may require. The S10 is the first of the larger contact expansion modules. And then what you would do here is you've got 4 normally open and 1 normally closed. So part of the housing isn't used, but it's the same housing as this one, the S11. And this is where you get 8 normally open and 1 normally closed contact expansion. So if you've got bigger contact expansion requirements, then you can use this. Again, you plug it in, there's no additional wiring. You can use this as a give you bigger contact expansion. We also have the S20 within the range, and this is semiconductor outputs. So if you require semiconductor outputs in your system and not volt-free contacts where you run your control voltage through, we can do this with the S20. All of these relays, when you purchase the relay, you have options with the terminal type. We can have screw terminals, or you can have spring terminals. I would always recommend spring terminals because the way they operate, they are dual chamber. So you press one side of the terminal and it opens one chamber, press the other side, it opens the other chamber. So if you have more than one cable going into one of the terminals, you're not actually putting them into the same chamber. Other reasons, they don't come loose over time. They're quicker and easier to wire, so you can reduce some of your wiring time, etc. But the cost of the two terminals is the same, so it's just purely down to personal preference. So that's the Sigma range. So now we're going to move on to the latest of our safety relay range, and this is, say this very carefully, myPNOZ. And the idea behind this, you can see where it sits. It's not in the configurable range, as there's no software involved in how it operates, but it's more configurable. It's configurable in its design from the creator. So basically, the way this operates is you would go onto the creator via our website, and you look at what you require from your safety system. And I know that this is attractive to some companies who maybe have service contracts, or if you're, I mean, I was from a maintenance background, although being electrically biased, I know that some of the mechanical engineers in the maintenance teams that I've worked in would not have been able to, or comfortable with looking at software to see what's going on. So they were comfortable with looking at lights on the front of safety relays. So this still satisfies that requirement, but you can build bigger systems, and we'll come on to some of the features as we go through. So you will always have a header module, which is the YH1, and this is your global safety function, or you might see the abbreviation GSF during the presentation. And this is generally where your emergency stop would go in, and this is your central point. And then we can have input or output expansions. So the difference here from the previous Sigma range, the Sigma range, you couldn't really have any input expansion. With this myPNOZ range, you can expand the input requirements as well as the output requirements. And there's all sorts of different modules for different types of expansion. And then they are clicked together via a backplane, which I've got an illustration on later on, which we can come to. So, as I said, you'll go onto the creator, you custom your requirements within the creator, and then you can simulate that as well in the creator, and then you add it to your basket within the eShop. You are given then an ID, a personalized part number for it. And then you also get some extra detail in the documentation that comes with it. So you're looking at what the configuration is. It gives you some wiring examples as well. But the ID or the part number that comes with this is going to be your own individual one. So what you can do from there is you can reorder that or set that part number up. If you're an OEM and you're repeat building machines, you can set that part number up, and that can be your continuous part number allocated to that specific machine. On each of the units, depending on which type it is, you will have different parameter settings which you can adjust with a screwdriver, very similar to the Sigma range. But you also have a configuration mode where you put it into the configuration mode, and it then scans what it is and sets the safety function. The software, there's no actual software for how it operates, that it's just purely the configurator on the website. So as you can see here, there's various the ways in which it goes. You can select it from the eStop. You get the individual modules, you can assemble them, or we can assemble them for you onto the as we send it out. With the myPNOZ range, you can also do zoning. So you will have your global safety function, but then you may have input and output zones. So we've got a simple application here of a palletizer machine where you may not want to stop the whole machine. If you're just accessing certain parts, you can do this with the myPNOZ range. which is different to some of the other standard safety relay applications. And here is the configurator, the wiring examples that you would get for the different zones. So on the left, you've got your global safety function, and then you've got your two separate zones with your different channels, your output requirements, etc., and the different modules. And it would look something like this as it goes together. Again, you can see from here, you've got your operating dials or your resets, etc., maybe timers, and also the LED indication of your different channels, whether the system's healthy, whether the power's on, and which channel is active or not. This also can be exported out to ePlan, and that will give you then be able to put that into your schematics or your documentation which is supporting your machine. Again, here, this is a larger example where the modular packaging plant, where there's more zones, and it might be that you've got one which is one global e-stop system, and then your interlocking doors or light curtains, etc. You might not want to stop every machine, but you can do that. So there's some quite large applications which you can do with this myPNOZ range. You can see here we have various different types. So we have your global safety function, and then you have four input modules. You have timer modules. You've also got outputs, so whether you've got semiconductor outputs, which are instantaneous, you may have a signaling output with it as well. You have instantaneous relay contact outputs, so if you've got to run your 24 volts through there. And then there's different varieties of the number of outputs and inputs that you would like. And then again, the terminals are spring or screw terminals. I know the part numbers, so I can tell you now that these part numbers 751003, that is the same part numbers that are used in some of our other ranges for the terminal blocks. You can see here we've got the run, stop, and config. So as I mentioned earlier, you put it into run mode, you can stop the system, but when you've set your system or you've made any changes, etc., you put it into the config, and then it scans the system, identifies the modules which it has, and then you leave it 5 seconds. You can put it back into the run mode, and it will then operate. Again, you've got your reset. So as with the Sigma range, if you've not got short circuit detection requirements from the relay, so maybe you're using coded switches or light curtains where that sort of detection is being done within the input device, you can use the left hand side. So you can have it on auto, you can have it on the rising edge of the reset button, so as the reset button is pressed, the reset will be initiated, or you can look for the reset button to be pressed and then released before it goes. And we've also got automatic start with a startup test. So every power cycle, the contacts need to be broken and made to do a startup test on the machine. If you go down the right hand side, the resets are the same, but what it means is that you actually got maybe a volt-free contact going into the input device, input terminals. Therefore, you're going to be doing your short circuit detection via the relay. The other two dials, you can see here, you've got a timer for off delay and a timer for on delay. And then dependent upon the configurations of what you're going to do in seconds, then you can see there that you can modulate the timer to the exact timing you want. And these are the tables in which you can use for to get to them, to the amount of time that you require. As I say, there's no software to physically type in a timer value. You just use the dials as you would with the Sigma range. As we were saying about the mechanical features, there's no jumpers on the top. of these, it's done via a backplane, so you take it out and you slot it back in. And there is a module bus across the back. This is how it does the config, but this is how they also talk to each other, which is mounted within the sort of dim rail profile in the back of the module. So replacing the module is very simple. You just unclip the top clip, you can see there, the black one, that releases the module from the dim rail. Take it out, slide a new one in, plug your terminals back in, so you haven't actually got to rewire anything, and then away you go. You just got to make sure that it's the same module you're putting back in, otherwise your system won't be the same as it was, and that you've actually took note and detailed. You can check your documentation, because you can put your dial positions into your documentation that you'll get, so just double check your documentation to make sure that you have actually recreated the exact system which was in the design. And you can see from here, these are the various Pilz products which are compatible. So basically we're saying virtually everything is compatible with the myPNOZ range, and it's not limited to Pilz products. You can plug other manufacturers' sensors and e-stops and light curtains, etc., scanners into this range of products, and they will operate just as well. So now we're moving on to the Multi 2 range, and this is the first part in the configurable controller range. So this is where you use software to actually configure what the system is doing. And you can see from here we start with the MCO, which is a new product, the MB 0.1, again another new product. MB 0 and MB 1, they've been around a little bit longer, but this is what we class as the Multi 2 range. So they're software configurable flexible systems. So the software which you can use is when you download it, version 11 upwards, comes with the free licensing, and there's again a range to cover all requirements of a configurable system. So if you've got a very small system, you can use the MCOs. It's only got 8 inputs and 4 semiconductor outputs. They all have the 4 test pulses. So the way in which you do short circuit detection is slightly different. You actually assign a test pulse to a specific input going through a volt-free contact. The MB0 has 20 native I/O, 4 semiconductor outputs. The first 4 and the last 4 inputs can be used as standard outputs. So if you don't need all your inputs, but you want to do some standard outputting, you can do that. It has a maximum of 6 modules to be expanded on to the right hand side, and we can put, which I'll come on to in a bit, there's contacts expansion to the left hand side as well. And with all of these devices, with the semiconductor outputs, we can actually do PLE single channel. There's a feature within the software which is called advanced fault detection. So this is where you're looking at the feedback loop of your contactor or your switching device. So you're looking for that signal to go off on de-energization within a period of 50 to 3000 milliseconds, and back on de-energization on between 50 and 3000 milliseconds. So we're actually monitoring the feedback loop signal going on and off in both directions of the activation of that output device, and that allows us to do achieve performance level E in single channel mode. I will say, although it's got 50 milliseconds, don't use that because it's way too short a time for the scan times, etc. You'll just get output faults. You want to be looking at around about half a second if your system can cater for that as a reaction time. We have the MB1. This is for larger projects, so you've got 12 expansions to the right and 6 standard output module expansions as well. So if you want to do some standard requirements where you don't require fail-safe inputs or outputs for that. And we also do a version which has burner management certification, as with the S4, which is the S4.1, as you've seen before. So what we're looking at, there's also connectability, so we can connect these base units, and it doesn't matter, they don't have to be the same base unit. You have to use the same field bus, but you can have a variety of the base units within the software, and you can then connect them. If you're going to go with Safety Net P, you can put that module on. If you're going to use the Safe Link module, then you would use be a safety bus, which is a CAN-based protocol. But you can connect them together and do that within the software. For different applications, so if you've got laser scanners, we also have the pit reader software. We have motion blocks. There are special blocks for the burner functions. All these blocks are available in the software. The software is very easy to use. It's just drag and drop software. Configure it as you go. You may draw some lines. You will draw lines from between your inputs and your outputs. It's Boolean logic and or exclusive ors, nots, things like that. And you would use that software. Personally, I'm no PLC programmer by any stretch of the imagination, but I can use the multi software pretty proficiently. The various blocks that you can use, you can see here, you will select an e-stop, safety gate, light curtain, two-hand controller, whatever you want to do. There's timers, counters, you can do equals to knots. There's diagnostic words and diagnostic points. So what you may use with the diagnostic words, you can start to pick statuses of e-stops. So it might be that you can pick out that there's a single channel failure, that there's been a detection of short circuits, that it's been pressed and released and ready for reset. And you can pick these parts out by your diagnostic words, and then you can use that to send back over your comms cards, and we'll come on to the communications in a minute. All these sort of things are available. You can do some quite clever stuff, not high-level maths or anything like that, but if you're looking at general safety systems, then with the expansion and expansion capabilities to the right and the left of the various modules, you can do some pretty big systems, and you can also network them together. The software looks a little bit more like this, so you can see here how you draw the lines, and we also have a dynamic program display, so you can plug in and see what's going on with the system. So as you can see from the illustration, these lines are green, and this is part of the simulation as well. So when you're designing your system, you can simulate it and click on the different inputs to activate them or deactivate them, and then you can pick up then if your system's going to operate as you require it to, and pick up any potential errors or scenarios where the safety system might not operate as it's required to. So the MB1 base unit you can see here is the most intelligent one that we have in the range. All the other controllers have a SIM card to hold the memory, whereas the MB1 uses a USB stick, which you can see the little black plug in the front. It also has the Modbus ports embedded into the front of it. So this is Modbus TCP, and so you can talk this out then obviously to screens or PLCs or any other devices. If you've got the pit readers, then this is where they would plug into. And it's got a larger capacity from the connection point capacity from 1024. With this Ethernet interface, you can communicate, as it shows here. There's the reader at the bottom. It's still only 45mm wide, but it has no native I/O. It only has the 4 test pulses, and then you can pick the I/O requirements that you want onto the right hand side, as we said before, up to 12 cards with 6 additional standard cards. But you've got a real-time clock, you've got an illuminated display, you can get a little bit more information from the MB1 as a unit rather than you can from some of the others. The MB0 said 20 I/O, of which 8 can be used for standard outputting, but you've only got the 6 expansion modules to the right-hand side. The software, as I've said before, is the same for all of these units. And here's the difference in the where we hold the memory card. So you've got a SIM card type application for the MB0, or the MB1 has a USB stick. You can actually hold more than one program within the USB stick. So if there's a requirement to swap over, you can swap seamlessly with the base unit. However, there's password requirements and things to stop that being done by accident or by unauthorized people. But if you need to, you can hold more than one program within the unit. The expansion modules for both of the base units are the same expansion modules. So we have fail-safe 16 input module to just give you pure input expansion. If you've got some analog requirements, so you're looking at maybe monitoring levels or temperatures, etc., for more process applications, you can use the 4AI module. So this gives you analog capabilities in a fail-safe inputting capacity. You got the 8Di2 DOT. So this is a dual pole semiconductor output and 8 digital inputs. So you've got the 8 in and then 2 dual pole outputs. 8Di4Do. So this is 8 inputs and 4 individual semiconductor outputs. Again, these are the ones where we were talking previously, where we can do performance level E, single channel, if we have the advanced fault detection. We have the 4Di, 4DOR. So this is 4 inputs and then 4 relay outputs. It's worth pointing out at this stage that the relay outputs singly are performance level C. To get performance level E, you would need to series them up. So you basically have 4 performance level E outputs or 2 performance level E outputs. And the reason you series them up, that's how you simulate that configuration we have in a safety relay. So you'll notice with any standard safety relay, there's 2 force guided contacts in series. Well, that's what we have to simulate by seriesing these up in the software, but they are individually configurable. For standard applications, we have a 14 digital output card, and we also have input expansion as well, standard input expansion. So this is the 8Di2 DOT. So as we've said, you've got 2 safety outputs, which are dual pole using the semiconductor technology, and you've got 2 test pulses for detection across short circuits. So these are the input contacts. The analog module, the analog input module, as I say, is only an input module, but it allows you to do some process safety applications. You got to limit you can limit the values and range monitoring. So you might look for it to be on within a certain range. So when you're looking at a certain height, you can see the sensor here. You might be looking then at that capacity. So 4 to 20 milliamps or 0 to 25 milliamps. And you can have up to 6 analog values can be transferred, and then that can be sent out if you need to over a field bus module. But we can look at pressure, temperature, speed, diameter of grinding wheels, removal. You can look at loads. It all depends on what sensor you're going to be plugging into it, basically. But we can look at different analog values, give you a set range which is safe and a range which is not safe, and then you can do that within there. So there is specific function blocks within the software which you can use. and these are all pre-configured and certified function blocks. So it doesn't mean that you have to write your own. We can do that. That's already been done for you and is loaded into the versions of the software. The speed monitoring, we can do that with either single or 2-axis speed controllers, and they'll do safe stop 1, safe stop 2, speed range, standstill detection, overspeed. You might have it that you've got certain safe modes which are required, and you need to have a reduced speed to that would be your risk mitigation for your safety system. So you can do all that within there, and there's also some within the software, there's wizards which you can look at, and you can change which type of drive, whether you've got screws, belts, chain driven, and you can put your ratios of your gears, etc., in to help you configure the right speed. And then, like you say, you can select your ranges at which you want to be safe, to be non-safe. If you've got to monitor standstill before you allow access, so you may have a request to enter, bring the machine to a stop. We monitor that with the safe, with the speed monitoring modules to allow access. They will accept either incremental encoders, sine cos encoders, or you can do it with proximity switches if the encoder is not always possible to fit one. It doesn't get onto the shaft, etc. Space is a limitation. You can do all that via there. And like I say, we've got single or 2-axis variations. If you're using some encoders, then we've got a box as well, which is like a smoothing box, which sort of tries to eliminate some of the noise which may be coming down the line. We do pre-assembled cables, and we do also make a safe encoder ourselves, which is available. This is one of the safe relay output modules. So this gives you 2 safe relay outputs, and then these can also be networked together either via Safety Net P, as we mentioned before, which is an Ethernet, safe Ethernet based protocol, which is a Pilz protocol, or you can use it with the multi-link, which is a CAN based safe protocol. You can see from the illustration we've purposely put in various different types of modules on the bottom because all of them can use the CAN based protocol. But if you want to go to Safety Net P, then you will need to be in the MB1 is the only one that can really use that, or the MB0. So you'll need to be in the multi 2 range to use the Safety Net P protocol. With Safety Net P, you can have up to 16 multi-systems in a linear topology. It's got a fast bus network, and the way it would work is with any other safe network where it sends a signal and it expects the same signal to be returned, be evaluated, and then if it sees the same one, then we're like, okay, that's good, everything's okay. If a different signal comes back, it may then, or doesn't get the signal back, it will give it another go. If it doesn't see that back in a set time period, it will lock out the system. And that's how many of you probably know fail-safe networks work. You get 128 virtual fail-safe inputs and 32 fail-safe output bits within the protocol to share between the points in the network. With the multi-link, you get 32 inputs and 32 outputs. We have to determine, it says here, there's a cable length above or below 100 meters. And this is just to do with the fact that it's a CAN-based system, so you've got to consider baud rates. So otherwise, then it's going to keep dropping out on timed returns. So we've got to look at that, and you may have to consider as well screened cables over certain distances to give you to eliminate noise, etc. To go along with the range for any of the controllers, we have a link module which is called a PDP link, and then this can go out then to various distributed I/O systems, various distributed I/O. So we have the standard F8 PDP 67. 67 means IP67. 8 ION. So that's the four plugs, dual channel inputs. You can do test pulses. You can configure them also to be the 2 plugs, 2 of the pins. So within the software, I'll start again. Within the software, you configure the specific pins. Some of the pins, the even number pins, if I remember correctly, can be configured to be outputs. So you can do standard outputting, and you can also configure them to be a 24-volt supply. So if you've got coded switches or light curtains going on, or as you can see here, there's an S-lock as well, then you can actually configure that the power to power the switch from the pin. The middle device is a high power version. So if you've got more power hungry devices on within the four connections, then what you can do there, you can plug an additional 24 volts into that, which will just boost the power from that for that device. And we also have a rugged version. For any link module, you can have up to 4 PDPs in series. So you can have 4 of these blocks in series. They are all 5 pin, and you can get crossover cables and things which will reduce some of the 8 pin variants down to 5 pins if you require. But generally what you do, you would have 4 in series, and then you can have up to 4 link modules per base unit. So that means you can have 16 PDPs out in the field, taking your e-stops, guard switches, light curtains, whatever it is. The one thing to remember is that the outputting on these is only standard outputting. So if you've got a switch where you're required to do personnel protection, so you've got a power to unlock device, it would not be safe to use a PDP, because that unlocking the signal must always be sourced from a fail-safe output, and these are not fail-safe outputs. So it's worth bearing that in mind before you do it. You also cannot do signals to safe torque offs on drives from these, again, because it's not a fail-safe output, and that for a drive it must be a fail-safe output. So there are some limitations, but it can also reduce a lot of wiring. It can give you quicker installation time. I remember working on a project many years ago now, and the company had a very short window to install a new system. So we looked at this as a solution, and they actually came back to me afterwards and said, "Do you know what, Jamie? If we hadn't have used these PDP devices, we would never have met never got the job done in the short time frame that we had." So there's various different application requirements. You know, some are cost biased, some are time biased. Some, it might be that you need more diagnostics out in the field, which you can get through via the LED illumination on these devices locally, which again can also be labelled up. So basically, the message is that there's various ways in which you can do it, and we can cater for a lot of them with that. As we know, with the multi-system being a standalone safety system, this is quite often going to be talking back to a larger PLC. So what that will do then means you can do this. You haven't got to hardwire it all. We've got all the different comms flavors of Ethernet. The more you could shake a stick at. So Ethernet IP, Profinet, Profibus still even can open, Modbus, EtherCAT, various different ones. These are all slave devices. So from our perspective, or when you're programming it, the actual program doesn't really care what module you've got on. Yes, you need to put the correct module on, but it doesn't really care what module you've got on. So you get 128 in, 128 out, and they are just on and off, and you can put them out. You would load a GST or XML file into your PLC software, whether that's TIA portal, whatever it is, and then it becomes available. You can see it and you can map to it. It's very simple, but it also allows you to run signals to the safety controller, stop signals, other standard things where you can then within the software within the multi-configurator software use an AND block which you configure for standard functions. So your overriding control is your safety device, and that will go into the top of the AND block, but you don't have to then hardwire out and through relays, etc. You can just seamlessly send these commands across the bus, and the multi will make the decision then on whether it's safe to run, whether it's safe to or not. So quite a seamless integration. Some of you may have seen my colleague Jason's done some very good webinars and talks on the IAM requirements. So we have the PIT reader here, which talks about via Modbus for safe mode selection, identification, etc. The function blocks are available within the software. Also in these talks, we've looked at security bridge and the requirements coming forward with safe OT networks. So you can use this security bridge to prevent malicious damage or malicious access into your safety controllers, whether that's the multi or the PFS 4000, or actually a third party controller or PLC. You can use these safety bridges. So it's something that's going to be coming into the new machinery regulation in 2027. So it's very worth getting up to speed on. To complement the controller software, we have PNOZvisu, and these works hand in hand with the multi-controller software, where you can or the PLC or the PFS 4000 controller software. You can upload projects into the PNOZvisu, pick up the tags, and then it's very simple drag and drop tile-based requirements with predefined images, or you can even upload images yourself. I had to play around with one, and you can have pictures from your phone and all sorts of things coming up. Then you can also use them to give, as you can see here, e-stop button has been operated, signals are invalid. There's all sorts of different statuses that you can bring up. I worked on an application once where there was a food environment. There was water ingress into a lot of e-stops. They were losing a lot of time. So we actually used the multi and the PNOZvisu software to say, okay, well, when there's been an e-stop active, it will come up red, and it will say it's been pressed, or if it's been released, it will say it's been released and ready for reset. It's red. If there's been a failure of the e-stop in the way of a single channel failure or short circuit detection, then that e-stop symbol will come up, but it will flash red. And the reason for this was that the operator straight away can look at that, and if it's a solid red image, he knows it's his job. If it's flashing red, there's nothing he can do with it. Call the maintenance team. It probably removes 10 to 15 minutes of operators pressing and releasing e-stops and trying to figure out which one it is. Well, it tells you exactly which one it is. You could even take a picture of it on your phone if you wished and have the actual image come up. But it tells you what's wrong, and you can identify very quickly whose responsibility it is to look at. So yeah, very, very useful tool. Again, like I said earlier, I'm from a maintenance background, so it's often one of my first thoughts is breakdowns. As you can see, there's all the different varieties of Pilz products again that we look at. The safe encoders pictured in there as well, which can work with these devices. In the latest versions coming out now, we actually have the FSOE EtherCAT standard module, and also there will be a fail-safe version, so FSOE fails safety over EtherCAT protocol, and I believe that's going to be a master version as well. So we can do a lot of with the larger systems as well, talking to drives, etc., and everything else that's going to be plugged into an EtherCAT system. We have another system called Key in Pocket, which is to do with taking your keys into the machine or out the machine when you're to work as like an intelligent trap key kind of system. All that's built in, and also you can see there's a standard 14 digital output module as well, which can be connected in. So this is the FSOE master, which is going to be available, and this is the MC0, which is a new product to us. So it's just got 8 safe freely configurable inputs, up to 2 can be configured auxiliary outputs, and 4 fail-safe semiconductor outputs and 4 test pulses. So if you have if you want things that you can't quite do with a standard relay, but it's not a massive system, you can buy one of these MC0s, and it may very well just be the perfect job. MB 0.1, again, this is new. This is the advancement to what was the multi-mini. So the only contact expansion you can put on the side are just relay outputs, which will all go on or off at the same time. They're not individually configurable, but again, when you're looking at certain applications, if his cost is your driver, this may be the one for you. So finally, we're going to move on to the PSS 4000 range, and this is our not just safety PLC, it does standard control as well. It's a very capable PLC in its own right. You can program it via the PAS 4000 software. The licensing for this, there isn't a license that you have to keep up with every year. You license the individual application. So when you're budgeting, you don't have to have X amount of thousands of pounds just to maintain a license for the system. You can allocate the license, and it's pretty cost effective as well. It's not a lot of money, and they're done via tokens within the software. It's very flexible. There isn't a fixed backplane. You buy a header module, and then you buy the input and output requirements, input and output cards you require. We can do multi-master systems. We can put them on various other networks as well, which are embedded. There are still 4 railway versions of this as well. So you can have up to 128 controllers are possible in a project, and 64 safety net P connections are possible per controller. So, and you would use this our software, which is PAS Connect, to link all these together. As I say, it is a very good PLC in its own right, as well as the safety PLC. For smaller machines, we have various different software languages available, which I'll come on to in a bit, but we do also have a multi version of this for smaller machines, which is a little more easier. And then we have the decentralized IO systems, whether they look more like the PDP, so the PSS 67s, which look very much like the PDPs, or we have the PSS universal headers, which we'll come on to in a bit as well, for distributed IO systems. So you can see here you have a header module, and then you buy the terminal block and the card that you require, and so you build up the system as you want. If you've got a larger system, you can have end stop, so you would put it on the right hand side and a cable link just to a different row on the DIMM rail, so it's quite flexible in how it can fit into your panel. But the base modules, that carries the supply. At times you may need to put additional power supplies in. It's generally the outputs which are the power hungry devices, but you can then also configure within the software the actual ampage that they're going to be drawing to try and give you a more realistic view of where you need to have a power supply. We do safe inputs, safe outputs, standard inputs, standard outputs. Again, we have analog capability. We have safe speed capability. And we also have some fast acting modules. So if you've got certain areas of your program which need a very, very specific fast reaction time, then you can use these, and they work independently of the scan time of the overall program to act fast within that. We have different versions, railway, high temperature versions, and they're available within the range to try and cater for as many different application requirements as possible. And here's some more of the information out of the catalogues, which gives you some of the operating parameters. Again, you can use the security bridge with it. So this will allow or prevent people gaining access to your PLC and making changes, malicious changes that you don't want. Again, bear this in mind with the machinery regulation coming in, and these are going to probably be law to have this sort of thing, or some sort of OT network protection coming up. As we talked about the software, you have what looks on the screen there. You may think it looks very similar to the multi software we looked at previously, and that's because that's what it's based on. Trying to be simple. I said I'm no PLC programmer. I can muddle my way through this one still, but we can do structured text, instruction list, ladder. When you want to do more technical things with maths, etc., and comparisons, then you can use that. But you can also write some of these and write some of these function blocks and drop them into your multi-program as well, if you want to try and keep the view of the system quite simple. And there's various languages that the software is available in. Again, we're just showing here some of the function block capabilities. It also works again as with the multi-system with the PAS-Visu projects software. So you can do your projects across there. You drag it, you load your program into the PAS-Visu software and allocate the tags, and you can export via CSV files, etc. So you can do logging and trend monitoring of the system. They have Safety Net P, the Pilz failsafe protocol embedded as before, and this is your sort of standard and failsafe data transmission. You can see the principles of there on how it operates. And again, you can look at it, map it within the PAS Connect software, and you map your topology within that. You can have various projects. What you can do with the 4000 as well is you can have a ring, and so redundancy, but you can have various, you can open one project but have various programs within that project, and then these programs then you can execute in different PLC headers across the ring. So what that means then is you don't you can take part of the system down and move it around. We did a project once where we had 2 fiber rings, and what we had was line of sight across a 7-kilometer distance, and we wirelessly sent the communication across there. So one program was operating across 2 sites, 12 PLC headers, and it was all operating in one system, and we could wirelessly send it across and ping it in less than 10 milliseconds from either site. And it, there was 2 wireless transmitters across, and it was a very successful system. So the capabilities, we're willing to have a look into it with you if you've got some off the wall kind of applications, and you know, we can always see and work with you to see if we can cater for them. As with the others, we've got all the different flavors of Ethernet that you could care to shape a stick at. So they're embedded in Profinet, ProfiSafe, Ethernet IP, SIP safety, Modbus, CANopen, EtherCAT, UDP raw. So we can cater for all different applications. This is the PSS Universal 2. So this is the sort of distributed header block. But the unique thing about the PSS U2 is that actually, although it works seamlessly with the Pilz headers, it also works with other PLCs as a distributed header. So, and in a fail-safe way. So you can see here, this is TIA Portal. So the concept is the same as you buy a header block. The architecture is a 3-piece architecture. You have a backplane, then you plug your terminals in, you can plug your card in, and you just build up what you need in that configuration. But then you can drop that into your TIA Portal or your RS Logix software, and it will recognize it and it will operate seamlessly with the other PLC headers, with the other main PLCs. So if you have got, and we do standard and fail-safe cards for this also. I know people that have used this before just for their fail-safe remote requirements, because it's Pilz, it stands out as the safety thing. But also from a cost perspective, if you look at the cost of these compared to the some of the other distributed headers, these are quite a bit cheaper, but just as good. So it's always an option. It's always an option for you to look at, and something we're happy to explore. As we spoke about the architecture, you can see here there's a 3-piece architecture. You have a backplane, you have your card, and then you have your terminals. So again, it gives a bit of flexibility, but there's things where it's not. If you're going to remove the terminals, there's no chance of it arcing on the backplane. Again, it's a safer architecture which we can use. So we're sort of drawing to a close here, but you've got your 3-piece architecture. You've got your structured cabling, so easy operation, but the port density is quite defined and tight. And also with the LEDs, you can easily find an error because it will flash red. You'll know exactly which one it is. You can see from your system, and then define where the fault is. Just quickly to have a look at the different modules we do. So you've got your 8 inputs or 2 digital outputs up to 8 amps, or 8 digital outputs, half an amp. The 8 amp ones are relay outputs. The half amp ones are semiconductor outputs, and we do 2 amp semiconductor outputs as well. And then there's various different standard cards, and the different speed modules, analogs, all that's available as well as the additional power supplies if required. So you've got the Profinet ProfiSafe version or the Ethernet SIP safety version, and you can just specify these. You see the part numbers are slightly different, but you can get these, and they will be available to work with the other applications. So basically, to wrap it up, guys, thank you for today. The message I hope you got from the presentation is that regardless of your application, your system requirements at Pilz, we're confident we can cater for that from a safety perspective and from a standard perspective with the PSS 4000. I hope you found it benefit today. If you want to know any more, please feel free to contact us, and we'll be in touch, and we're more than happy to talk to you about your applications. So again, thank you for your time today. I hope you all have a great weekend, and we'll see you soon.